Question number 24. A vertically polarized beam of light is incident normally on a polarizing filter. Vertically polarizing. How is it now? It is now looking like this. Now this is the kind of beam that's coming here. Transmission axis of the filter is at an angle of 40 degrees to the horizontal. So the polarizer, this is 40 degrees over here. This is your transmission axis. Which means what is the angle made by this angle? This is your vibration, and this is your transmission axis, T axis, and this makes an angle of 40 degrees over here. It means this makes an angle of 50 degrees with respect to the T axis. Then what is the ratio of the amplitude of the transmitted beam to the amplitude of the incident beam? Now we know that the transmitted beam will have an intensity equal to I is equal to I naught cos square theta, right? In other words, I by I naught is equal to cos square theta, right? What is I here? I is nothing but transmitted. Now, how is I related to amplitude? I is proportional to A square. So this will be A by A naught, the whole square, is equal to cos square theta, or removing the square on both the sides, I get A by A naught is equal to cos theta. Now, what is this theta here? Theta is not 40. This is 40, but this one should be your theta here. What is the angle made by the vibration with respect to the transmission axis, right? So this is your transmission axis. This is horizontal, okay? The vertical, what I want. So therefore, this angle is 50. So let us find the value of cos 50. So this will give you, let me take my calculator to find out what the value of cos 50. This is 50 and cos 50 value would be 0.642. 0.6427. So the closest is 0.643 or 0.64. Answer is CO. Because I substitute here and I get 0.643.